All right, today we're looking at volume by slices. Let's go ahead and get started here. The idea for volume by slices is we have a shape, some form of shape made by a function, and it has a base. This is the base of that function. We'll say this circle is the base. And we want these vertical slices. So vertical slices, right there. These are our vertical slices. Now, these are not just vertical slices. There's 3D slices that create a 3D shape. So, like this. So looking from the top, they just look like slices of that circle, but when you drop it into a 3D plane, they're actually a shape. In this case, they're squares. Not always going to be squares, but they're squares. And we're going to take an infinite number of those and sum them all up to get a volume of a shape. So this shape right here, we have a bunch of infinitely small or infinite squares. You can see them inside there. So each one is a square, and we summed them all up, making this 3D shape. That's the idea. Now, to do this, we're going to need to integrate the area of one slice. All right, that's what we're looking at. Integrating the area of one slice. So let's look at this one. Okay, this is the problem we just did. We have this shape. 1, 2, 1, 2, 1, 2, 1, 2. This is a circle with a radius of 2. All right, and it has square slices. So we have a slice that if we were to drop it flat would end up being a square. There we go, square slice. Now, the first thing we need is we need the area. We said an area of one slice. Well, area of a square is base squared. So we need to figure out what our base is. Now, a lot of people are going to say, well, it's the function. You said in the beginning, the base is that function. Well, the issue is that's not a function. If we rearrange this, we get y equals plus or minus square root of 4 minus x squared. That's not a function. What's a function is y equals square root of 4 minus x squared. And this does not make up the whole base of the rectangle, or the square. This part right here only makes up this half, because that is only this part of the circle. Right? But we have to use this because this is a function. Plus or minus is not a function. So what we need is we need to make this take up the whole base of the circle. To do that, well, it's symmetric, it's a circle, so we're just going to double it. We're going to say our base is 2 times square root 4 minus x squared. And then we're going to plug it into our area formula. So our area is going to be 4 times 4 minus x squared, because we squared this. And so we're going to do the integral. I'll pull a 4 to the outside, 4 minus x squared dx. And we just need bounds. Well, the bounds of this are going to be from negative 2 to 2. And this will be our integral. We can solve this by hand, no big issue. I'm really just working on setting it up here. Now, as I said a minute ago, they're not always going to be they'll be squares. Sometimes it might be something like this, semicircles. So when we look at this one, we have this triangle, but our slice is a semicircle that looks like this. Okay, there's our semicircle. All right, so we need the area of one slice. Area of one slice is 1/2 pi r squared. So we really need to figure out what the r is. Well, the only thing we have to go on is the function. The function is this whole distance here. So the function would be the diameter. So y equals x is 2 times rr. So that means r is going to be x over 2. So there's our radius, just half of that. And so now we can set up our integral. We do the integral from 0 to 3, because this is the line 3. I'll pull the 1/2 pi to the outside. X over 2 squared. Or let's say pi over 2. We'll go from 0 to 3 of x squared over 4 dx. And this gives us the volume of that shape. All right, I could do a few more problems setting up these, but it's really just going to be very similar. So let me know if you have any questions. Y'all have a great day.